Today, the goal of this talk is basically to give you guys an overview of some of the lessons that our team has learned trying to build AI agents that work in real enterprise settings, that are reliable, that do what you want them to do. As kind of alluded to, Factory builds a platform for particularly enterprise organizations to delegate tasks and to a certain extent collaborate with AI agents across the whole software development lifecycle. So that means you probably all are familiar with coding tools that help you when you are in the IDE, you're actively driving the process and you're kind of handing off something like generation of a code file or a number of code files, or maybe you connect some MCPs and you get it to like send, create a ticket or something like that. Like that flow can be quite helpful, but as you move into situations where maybe it's a multi-billion-dollar biopharmaceutical company or a healthcare product or financial institutions, there's a higher degree of reliability and a higher degree of integration that's required to get that same level of capability. And so in those environments, there's a lot more that you can do than just kind of add a simple kind of tool loop or a simple kind of while loop inside of your LLM in order to get systems that can execute on varying tasks, right? Coding, code review, writing technical documentation, incident response. So ideally, you guys can come away with this. It's going to be a little bit of a rapid fire, just here's some tips, here's how you can make it work. And hopefully, if you guys are building AI agents, you are thinking about deploying AI agents into your software lifecycle or into other products you're building, you can kind of take some advice from this. I always like to start just talking about what is an agent. It's kind of like AGI, right? Everyone has their own definition of what an agent is. At Factory, we see an agentic system as being something that demonstrates, first and foremost, the ability to plan. Any system that can make a plan of what it is going to do in the future, that could be one step, it could be multiple steps in the future. That is one of the requirements. The second is the ability to make decisions. A little different from planning where you're forecasting what your next step is. Agents have to make decisions all the time about, one, what direction should I go? Should I take this action or should I take that action? And so there's a lot that goes into making sure that your systems make the right types of decisions and evaluate the right context to make those decisions. The third and probably most important one is environmental grounding. Agents need to be able to read and write to the environment that they exist in, right? So if your system doesn't have all three of these, I think that there's a lot of terms that people throw around, workflows, LLM tools. There's honestly such a long list of these phrases, but for us, this is what an agent is. Not more, not less. Basically, what I'd love to do is talk through these three concepts and talk through a couple of techniques that our team uses to make our agents much better at planning, decision making, and give it the proper environmental grounding to make proper decisions. The first is you should think about how information is propagated from one step of your plan to the next, right? If you have an agent and you ask it to go through and maybe make a change to your code base, as it reasons through the different actions required, creating a file, editing a file, searching for some information, there is a strain of reasoning that is happening as it moves through. I'm going to search for this file in order to find the implementation. I'm going to now search for a dependency that I saw. Now I'm going to edit the next file. If you ever look at the reasoning traces of advanced language models, you can kind of see this happening in real time. As you go through longer and longer plans in your decision-making process and in your plan, more steps in your plan, you'll see that this reasoning slowly diverges from its original intent. Language models have limited context. You have to manage that context. Even Gemini with 1 million tokens can't take more than 6 or 7 long-form agentic steps without filling up the context window if you're doing the right retrieval in order to kind of move forward. So we talk about, inspired by robotics, this idea of like a pseudo-Kalman filter. Basically passing information on your trajectory from one step to the other and deciding what information is relevant from those trajectories in order to make better decisions. The second most important thing is subtask decomposition, right? If you say to an agent, please migrate my Java 7 code base to Java 21, it is not going to be able to do that. A human being probably wouldn't be able to do that either if the code base is large enough, right? What a human being, they're going to break that big problem down into a number of smaller tasks. Your system should be designed to A, do this programmatically, or probably more reasonably, B, guide the users to understand that that's how they should interact with your agent, right? So subtask decomposition is really important to get right in your product. This definitely gives you a very fine-grained control over the steps that your agent's going to take, but it does increase the chance that your agent makes a bad step. It decomposes a task and it adds irrelevant information, right? If you want to edit that file in that previous example, if it decides to search, then create a new file, instead of search, then search again, then create that file, it may end up on the wrong trajectory. So this does kind of, it increases the risk that you go off track, but it's pretty much critical if your agent is working on anything other than very, very narrow tasks. The third idea, again, inspired by AVs and other robotics problems, is model predictive control. So a lot of the time when you're working on autonomous systems, the challenge is, how do you get it to react to new information, right? So as you're working on a plan, you're searching. Suddenly, that original plan that you had to do X, Y, Z is wrong because you found some new information. How does your agent handle these types of problems, right? The way to get this to work properly can be varied, right? Maybe you have communicated or prompted to the agent, when you encounter these types of situations, you need to recreate your plan. Maybe you reassess the plan automatically at every single stage of your agent's actions, right? There's trade-offs to all of these. There isn't like a one-size-fits-all answer. For us in particular, when our agent creates a plan, for example, to edit some code files in order to fix a Sentry bug that it detects, it might go and say, I see this bug, I see the area of the code base. So my plan is analyze that error, go to the code base and find the trace that I see, and then edit that file to fix it. As it searches through at each stage, it's going to do a light reassessment of that trajectory and say, oh, well, maybe actually it's time to search this other part of the code base because I've just learned some new information, right? So model predictive control as like a mental model of what agents can do, super valuable. The last kind of, advice that we would give is explicit plan criteria is so critical for your agent to succeed when you're operating in a domain. Like, as someone building an agent, you probably have a customer in mind. You have some user journeys. You have a general sense of the types of plans that your agent might make. You can help it out by giving some of your domain knowledge, your human understanding of where agents are not working today by adding that explicit criteria. Maybe an agent shouldn't, have a super vague kind of textual based plan. It might have a plan that's composed of explicit actions or tools that it can make, right? So how you choose to implement this, again, can vary. For us, it's things like editing code files, creating code files, searching information, exploring, right? These are stages of a plan that you can outline and say, when you make a plan, try to frame it in terms of these explicit, steps or actions. This leads to an enormous decrease in going off the beaten path, but it definitely is difficult to build and scale as you increase the breadth of tasks that you want your agent to be good at. For us, we operate in a world where people come to our platform looking for assistance on code review. They come to our platform looking for assistance on incident triage, on coding, of course, prototyping. All these different paths have very different plans and criteria. And so we had to figure out a good way to kind of balance between setting all of the criteria in advance and allowing the agent to be flexible. We found that prompting with few-shot examples was actually strong enough to give that criteria inside of our planning module. But if you're operating in a specific thing, like, for example, customer service, you may find that this is something you want to actually hand off to your users, right? Like, maybe the users should be defining the steps that the agent takes. Hard to say for sure, but for coding, that's what we ended up figuring out. The next thing that I want to talk about is decision making. probably one of the best ways to improve the decision making of your agents is to implement some form of a consensus mechanism. When your agent has to make a decision like, I would like to edit this file with this specific information or make this specific change, or I want to take either option A or option B, like a classification style problem. LLMs are really great at inferring a lot of information, leveraging context, but at the end of the day, they're non-deterministic. If you can add a degree of consensus to your decision-making process, then that will significantly help problems that arise from non-determinism. So an example of this would be, just like top K selection. You have some classification that might happen like 3 times. You take the one that was classified the most often. There are some other techniques. For example, you can weight some of these in different ways. I won't go into like the full literature that exists on classification with LLMs, but there's a lot that can be done just by saying, let's run this a couple more times. At the end of the day, this is expensive, not only on tokens, but also on latency. If you parallelize and you do the whole thing well, latency is really not as much of a concern, but it is more expensive. So I would argue that this is most important when you know that there's important decisions to be made and you can't get it wrong or it'll mess up the whole trajectory. Because the only thing more expensive than running an LLM like 3 times is running an LLM for 15 minutes on the wrong trajectory. So earlier on, much better for these types of techniques. This one is funny because a lot of this stuff was actually written like months and months ago before reasoning traces were even available to LLMs. But it remains true that explicitly lining out how the LLM should reason through hard problems is a great way to improve performance. There are kind of a couple of different ways that you can do this. A lot of the model providers recommend avoiding having chain of thought inside of the outputs of the models, and I think that is actually quite true. So rather than, a lot of the early research was literature basically looked at things like, you should think step by step. You should create a bunch of different thoughts and then pick the best one. You should have like a tree of thought. You should have like a galaxy of thought and look through every single one of the thoughts together. And like this, actually like worked pretty well when the reasoning traces weren't available and the models didn't reason themselves. Now model providers are post-training these reasoning strategies. So it's generally not a good idea to say you should think step by step or something like that. However, in many domains, the reasoning is very non-obvious for a bunch of very common problems. And so if you can, and I think like medical agents are actually one of the ones where this is like most obvious. If you need to follow a specific step-by-step path in order to achieve something, rather than having your agent need to relearn that every single time, it's much easier to just lay that out in the prompt or in the system, or maybe and probably the best is retrieving the correct reasoning process for different tasks that you have in mind. OpenAI calls this, I can't remember actually what they call it, so I shouldn't have said that. But they have a name for this, where basically, you as your agent works through a problem, it will swap in and out the structured instructions on how to operate. Right? I think that this is like a totally reasonable technique to do. We found that to be actually very difficult to scale, and so I would avoid having too many puzzle pieces coming in and out of your agent. But that can be, if you have a narrow set of tasks, a great way to do this type of explicit reasoning. Fine-tuning. So I've been talking a lot, I think, assuming a pretty probably reasonable assumption, but for many of you, it may not be true. The idea that you're using like state-of-the-art models or foundation models provided via an API. That is not obviously the end-all be-all. Fine-tuning is a great way to get your models to make decisions. And there still is a world, like I used to work at Hugging Face. That was like born in the era of BERT-like models where you just fine-tuned on a smaller data set and you got classification that clearly outperformed the state of the art. That world is not necessarily the world of today. It seems pretty unclear if fine-tuning small models or having like a giant zoo for all of your decisions is the optimal strategy, especially for early stage companies. But if you are in a position where you have the data, there are very, very strong open source models that if you have an obvious, similar to the consensus mechanism, obvious like major problem, and especially one that sits at the beginning of your agent trajectories, it may be worth investing in fine-tuning a model to actually do that type of decision-making for you. The last is probably the most interesting one, which honestly could be its own 30, 45-minute talk, but simulation is an incredibly valuable way to make decisions in an environment that you can simulate. And so there's like so many asterisks here of like when you should do this, when you shouldn't. I'll give a practical example for software, and then you can kind of infer for other domains. When you are working on a coding problem, where you know that a code base has a set of like linters and tests that can be run to validate the success, or at least validate that your code is logical, self-contained, and passes those tests. If you want to give a really good answer, you should probably get to the point where you run that code on, run those tests on that code. And if you have the budget and the time, you should probably not give users code that doesn't pass those tests. And so simulating that by actually generating that code, running those tests, figuring out which one works, and then handing only the one that works to the user can be very, very worthwhile. This comes with obvious trade-offs on latency, on cost. If the user doesn't have a test suite, if there's many assumptions here that come into simulating out decisions, but you can also build out heuristics. For example, linting much faster, right? So maybe you don't need to run the full test suite. Maybe you can have your agent generate 3 plausible files, lint all of them, and pick the one that has the least amount of lint errors. There's a bunch of different ways that you can kind of simulate through different types of problems. One that is, honestly, I don't want to speak on its like accuracy or confidence because I haven't done any proper evaluations. Our team hasn't tried this, but we have read a couple of papers that LLMs that are being post-trained with these types of execution loops where they generate code, they run tests, they feed that back, they correct the error, are shockingly good at kind of like reproducing reasonable traces from code that they generate. And so there's even an argument to be made that if your domain is kind of in the messy in-between where you can't really properly run tests or run validation, this is where the simulation comes in. You can simulate that with LLMs and then use that as like a selection criteria. Hard to say exactly what's best for different domains, but for coding, this is probably the single most effective way to guarantee that your code will look better than what a single pass or even a couple of passes that a normal LLM will do. Environmental grounding. So this category has grown in importance rapidly over the last 3 to 4 months as LLMs have been continuously grown in capabilities. As someone who works on building agents, probably your single most important task right now, today, is to understand what the capabilities of the current model set are, understand the 6 to 12 month roadmap of the foundation model providers, understand where they are post-training different types of interfaces like computer control, like function calling, and then trying to infer where do you need to fill in the gaps and build AI computer interfaces, right? So as we all know, computers were generally built for humans. They were built for us to interact. OSs are built for humans. Web browsers, they're built for humans, right? And so there's a whole suite of tools that basically have all of this UX, all of this feedback, all of this information that is totally irrelevant for LLMs, which operate purely on text in, text out, and images. And so if you are working on, for example, a tool or an agent which wants to write code, it doesn't have access to a full IDE, right? It only has access to the information that you choose to give it. And so building interfaces to those critical pieces of information can make or break your system. Should your agent get the entire stack trace that comes out of a debugger, or should you parse some of that information and only feed it the relevant information? These are the types of trade-offs and decisions that you'll need to make as you continue to build the agent. And so AI computer interfaces remain the most important tool to doing that. I kind of touched on this a bit, but explicit feedback processing. If your agent makes a mistake, is it on the agent to realize where that mistake was? if you know where those different points of feedback are occurring in your process, you can feed processed versions of that feedback to it, right? So if an agent, for example, runs out of context, do you tell the agent, you ran out of context? Do you tell the agent, you ran out of context and there's 15 files here that don't seem very relevant? You ran out of context and these 6 files are definitely not relevant and you can remove these 4 for sure. You should think about these other 2, right? Those layers of added processing that you add will make your agent appear better and more reliable, right? And so anytime that your agent has these failure trajectories, you should really be thinking about analyzing them, figuring out what information did the agent have, why did it make a wrong decision, and as it makes that wrong decision, what could we do to get it back on the right path in order to solve it? This can be exponentially complex. And so if you have a workflow that would run for, let's say, 30 minutes or 45 minutes, you just won't be able to know every single possible failure trajectory, every possible edge case. But you do know, because of this other node right here, the interfaces that it has access to. So you can kind of infer a couple of the different points of feedback that it'll get and then make some decisions from there. Bounded exploration. So as your agent operates in an environment, there are a lot of different ways that it can lose the ability to understand the real world context, right? It can get lost into a rabbit hole, just like us. I mean, we're also very liable to go yak shaving while trying to solve a problem. Agents need some degree of bounded exploration to solve problems well. If your agent has a search tool, if it calls that search tool like 40 times, it's never going to solve the problem and your users are going to get quite upset, right? But if your agent never uses that search tool, it's not going to have the information needed in order to solve the problem. And so there is some degree of bounding that you need to do, or some degree of explicit kind of mode changes that you should implement in order to determine when is it exploring and when is it executing, right? So a lot of the time for us, we encourage the agent to do this type of exploration at the beginning of the process, right? So you say to the agent, at the beginning, you can also see this with deep research if you've ever used this. The first time you ask a deep research query, the agent will immediately return to you and say, here's a follow-up question on A, B, C, and D, right? That is a very, very narrow form of bounded exploration where it is allowed one follow-up question. And I think the prompt probably says something like, ask another follow-up if the user gives a bad answer, right? And so in that case, they've kind of decided that the best user experience trade-off of the agent coming back and searching is about like one stage, right? The actual deep research process that then kicks off, right, can run for 5, 10, 15 minutes before it returns a response. But it's basically a bug if you've ever seen it run for more than like 25 minutes because they have these types of limits on the exploration stage. These are the types of things that you should be thinking about for your product. How long is my user willing to wait? Is there a point at which there's diminishing returns to continue searching for information? And then once you've decided on those things, it's fairly reasonable to instruct or artificially constrain the agent as it works through those problems. This is probably the least useful advice for building the agent and more leaning on like almost like product advice, which is determine where humans should be involved. It is just objectively true that agents are not replacing human beings anytime soon for a degree of complex tasks. For something like software development, our personal belief at Factory is that there's so much leverage that a software developer gains when they are delegating tasks to these agents that although the role is going to transform, the human being has a role for the foreseeable future in building software. In fact, if anything, we think that there'll probably be 100 times more people who build software. Not sure if they'll call themselves software engineers, but there's definitely going to be a lot more people involved. Your humans are guiding these systems, and maybe it's just in setting the task and receiving the end result. Maybe it's just receiving the end result, right? Like for us, we have a code review product. That code review product is triggered by creating a pull request, and the end result is a pull request review, right? So the human is only involved in the final stage of that agent. For our coding, for our main platform where you interact with the coding agent, a human being can be collaborating the entire way as the agent works, right? Guiding it when it makes a mistake, providing new context as they see it in order to improve the outcome. So all of these decisions really rapidly change how your agent behaves. And so I would think very deeply about, is my product an agent that I want humans to be involved with? What is a practical or realistic amount of human involvement that we can expect? And do users enjoy interacting with our agents? Or is it a terrible, terrible experience? Our original product 2 years ago were fully asynchronous, fully delegated agents that operated off triggers, right? I create a pull request and a review comes. I create a Jira ticket and an agent jumps on that ticket and starts writing code. We actually got those agents to be quite reliable at creating code that most people would rate 80%, 90% similar to a human. But the feedback was very weak. People were like, well, what am I supposed to do with this? It went one step wrong on like stage 4. And if it had just gone a little bit more to the right, I would have loved this PR, but it doesn't work, right? So our thought process was, well, we should preserve a lot of that delegation, but there needs to be a human being in the loop if we are going to get truly human level quality from our agents. And so this can be a hard trade-off if your vision is, I want fully autonomous AI systems, but you have to be practical about where the technology is. Even with all of these techniques, you're orchestrating some very complex systems. Humans will likely be there. So that is pretty much it in terms of the kind of practical advice. Happy to spend like the last 5-10 minutes answering any questions you guys have about this or anything related to it.